All right, hello class. I hope you guys are staying warm in this chilly weather. We are now going into section 2.4, so we are going to be looking at solving quadratic equations, and we're going to be doing this algebraically in this section. So I want to begin by introducing the standard form of a quadratic equation. Our standard form is going to be written in the form of ax squared plus bx plus c and set equal to 0. You'll notice this is very similar to the standard form of a linear equation. However, what is our highest degree of this equation right here? Well, if you guys remember, degree stands for the highest exponent that occurs within a given term. So the highest exponent value. What is my highest exponent? Hopefully you said 2. And if you did, you are correct. Now, we've already discussed what parent functions are, but we know that when we're dealing with a quadratic equation, our parent function would be y equals what? X squared. Good. Okay, and the shape that that graph makes is a parabola. And we know that that just goes through the origin and it looks like a U. All right, and so we know that that's kind of the idea of what we're dealing with here. But now I have thrown in these letters A, B, and C, which are different than our variable x that we are used to. A, B, and C just represent some numbers. They're constants. Now, obviously, they don't equal 0, because if they equaled 0, it would make a term go away. So it can't equal 0. So we'll put that in parentheses, not equal to 0. But any other number is fine. Okay? Now, when looking at quadratic equations, there are actually 4 methods in which we can use to solve a quadratic equation. Now, we aren't going to necessarily go in depth with all of them, and I'm just going to mention some of them, and we're going to look at more in depth into some of the other ones. The first one is factoring. It's my favorite because it's kind of the easiest one to use. This is probably something that you've already seen when you were in high school, if you remember back to your last algebra class. It's just the easiest one to use once we get acquainted with the process. The next one is extracting roots, and again, I feel that that one's pretty easy, and the reason why is because the majority of you have been extracting roots in this class already, and you just don't realize it. We haven't titled the process of what you've been doing. The next one is completing the square. Now, completing the square is not a method that I like to teach. The reason why is I believe that it's a little confusing and it only works sometimes. I like a one-way works all the time method, and in fact, out of all of these methods, they will only work sometimes. But if you want a foolproof, you use this, you remember it, you learn it, and it will work every single time, then you want to learn the quadratic formula. No matter what problem I give you, no matter what numbers are in the problem, the quadratic formula will always get you a solution. The first process that we're going to look at is factoring. Okay, so we're going to do example number 1. And our problem is 6x squared equals 3x. Now, our goal is to put this into standard form. If you recall, we just learned standard form was everything on one side set equal to 0. So I need to move this over. My recommendation to you, in order to make your life super easy, is to keep the coefficient of the term that has the highest exponent positive. Don't move that 6x squared over here and make it negative. That's going to make your life harder. You can, mathematically, that's not wrong. You're just going to have a more difficult time. Okay? So instead, I'm going to move the 3x over, and once I do that, that is set to 0. Thus, I am in standard form. Now, solve this. You're solving for x. If you notice, I can take out a GCF, a greatest common factor. What do the terms 6x squared and 3x have in common? I'm sure many of you said 3. But don't just concentrate on the number. Concentrate on the variable as well. I have 2 x's on this term and 1 x here. So they share at least one x that I can take out as well. And that leaves me with 2x from here. I took out the whole 3x. A lot of people have a tendency to forget that when you take out that whole term, you need to leave over a 1. Because if I factor that 3x back in, 3x times 2x gives me 6x squared. 3x times negative 1 gives me that negative 3x. If I don't put that negative 1 there, if I left it blank or if I put a 0, then when I factor that 3x in, it's not going to give me that negative 3x I had here. So you got to have that negative 1 there. And we set this equal to 0. Now you'll notice you have two parts that I'm underlining with a squiggly and a underline. Two separate parts that are being multiplied together, set equal to 0. So when you go to solve these, you actually separate them and solve each of them separately for 0 and set this equal to 0. So x equals 0, because 0 divided by 3 is 0. And here, that's going to be 2x equals positive 1. X equals 1/2. So therefore, I have two solutions, x equals 0 and x equals 1/2. Now, generally, because we're dealing with quadratic equations, we probably are going to have two different solutions. It doesn't always have to be two solutions. There are certain situations where we may not have two solutions, but generally we will see two. So some notes that you want to make to yourself. Your goal is to get everything to one side. And you want to keep the coefficients of the higher degree variable positive. All right, excellent. Hopefully you felt okay with that. Let's go ahead and look at another problem. Example number 2. Okay, x squared minus 10x plus 9. Now, I highly recommend you to pause the video here. Go ahead and try this one on your own, and then go ahead and follow up with my solution after you have considered this problem. All right? Now, the way that we have to go about this is a little different. Some of you may remember how to do this, some of you may not. In this situation, I've already put the equation into standard form. There is no GCF, there's nothing I can take out, and we feel like we're kind of stuck, okay? So our very first thing that we're going to do is we are going to multiply our first and our last term together. So step 1 is to multiply A times C. Now, if you remember in standard form, this represents A, x squared, minus bx plus C, okay? So your goal is to multiply A times C. So I'm going to go ahead and do that in green for you. In this case, we would be doing 1 times 9, which just equals 9. Now, once you have figured that value out, what that value is, your next step is to list out the factors of value found above and identify the factors that add to the value of B. B being our middle term over here, okay? So you have just found that A times C equals 9. You're now going to list out all of the factors that get you to 9. Now, some of you may not have to do this. You may see it a little quicker. That's fine. I don't expect you to write it all out, but for the sake of just learning it, we're going to go ahead and write it out. So what are some things that multiply to 9? Well, positive 3 times positive 3 gives us 9, but negative 3 times negative 3 also gives us positive 9. We can do 1 and 9, or we could do negative 1 and negative 9. I can't think of any others because there aren't any others, okay? So then it says identify the factors that add to the value of B. So I'm going to put this little plus sign in black in between all of these. Okay, and I'm going to add them. 3 plus 3 is 6, negative 3 plus negative 3 is negative 6, 9 plus 1 is 10, negative 9 plus negative 1 is negative 10. And I need to see which one added to the value of b. b is equal to negative 10. So I am picking the one that added up to negative 10, which is right here. Once you have identified those two numbers, those are going to represent the numbers that go into your factors. So x minus 1 and x minus 9. Now, all of you know how to FOIL. So if I'd given you this first, you could FOIL and see if you end up back at your original problem, and you should. You set that equal to 0. Just like before, we now have two things multiplying each other, set equal to 0. So let's separate them and set them to 0 and solve. So x equals 1 and x equals 9. And therefore, those are your solutions. All right, let's look at another one. Again, I recommend you to pause your video here. Try it on your own because it's very similar to example 2. X squared minus 6x plus 8 equals 0. Okay, I'm going to go off to the side. I'm going to multiply a times c, which is 1 times 8, which equals 8. And I'm going to list out my factors of 8. That would be 4 and 2, a negative 4 and a negative 2, 8 and a 1, and a negative 8 and a negative 1. And my next step is to add these together and see which one gives me my middle term value. So 4 plus 2 is 6. Negative 4 plus negative 2 is a negative 6. 8 plus 1 is 9. Negative 8 plus negative 1 is negative 9. I'm trying to get the value of negative 6. So that would be these values right here, negative 4 and negative 2, which will represent what go inside my parentheses. So x minus 4, x minus 2. Okay, now I have two things multiplying each other, set equal to 0. So what can I do? I can separate them. X minus 4 equals 0 and x minus 2 equals 0, and solve for x. And those are my two solutions. Now, I haven't mentioned this yet, but in examples 1, 2, and 3, in all of these, when you find this value of x, you can go and plug that into your original equation. And what should happen is when I plug in 4 for x here and solve, I should get a value of 0 equal to 0, which makes a true statement. Likewise, when I plug in 2 for my x values, I should get this entire side to equal 0 so that it makes a true statement. All right, I'm going to do another example again. Once again, I recommend you to pause the video at this time and try this on your own. We're going to do x squared plus 10x plus 25 equals 0. I'm going to look at my value a times c, which is just equal to 1 times 25, which equals 25. The values that factor to give me 25 would be 5 and 5, negative 5 and negative 5, 1 and 25, and then negative 1 and negative 25. I want to add the values together. 5 plus 5 is equal to 10. Negative 5 plus negative 5 is negative 10. 25 plus 1 is 26. Negative 25 plus negative 1 is negative 26. Which one works? I'm looking for a positive 10. So it would be my first factors. So I have x plus 5 and x plus 5 equal to 0. Two things are being multiplied together, set equal to 0, so I can go ahead and solve these. X plus 5 equals 0, and x plus 5 equals 0, and solve. X equals negative 5, x equals negative 5. Now, some of you must be saying, Miss K, why did you do it twice? It was obviously the same equation. Obviously, we're going to end up with the same solution. And actually, we only have one solution in this case because our solutions represent the same number. How come? Why is it like that? That doesn't make sense. Well, the reason why is at this juncture right here, we had two parentheses that had the same values inside. We could have written that as x plus 5 squared equals 0. Okay, and if we had done it in this manner, then we would have known that we were only going to come up with one solution because our two parentheses had the same thing. So that would be x plus 5 is equal to 0, and we would get the value of x equals negative 5. Either way is fine. If you noticed it, awesome. I'm proud of you. If you didn't, that's okay. Now you recognize it. It's not a big deal. Whether you recognize it or not, you end up with the same solution. All right, looking at another problem. 9x squared minus 6x equals negative 1. I want you to look at this problem and compare it to example 1 through 4. And I want you to pause the video and generally look at this problem. What do you notice is different? Take a look at that. All right, while you pause the video, hopefully you said, okay, well, one thing is this problem isn't in standard form. A lot of the problems you've given us so far have been in standard form. So I need to move everything to one side and get it into standard form. And set it equal, oops, excuse me. Sometimes this mouse acts a little crazy. And set that equal to 0. Awesome. Now, hopefully you identified one more thing that was different. In example 4, what was the value of A? Since there is not a number written here, it is an understood 1. What about example 3? Again, it was an understood 1. What about in example 2? Again, it was an understood 1. Now, going to the example I just asked you, what is it? It's no longer the number 1. Anytime you have to factor and A does not equal 1, you must factor by grouping. We're going to write a little definition here. Whenever A does not equal 1. Now, we already understand that A can't equal 0 as well. We said that at the beginning, that you're not even dealing with the standard form quadratic equation if A equals 0. So that's already understood. So I'm not going to rewrite that because I don't want to confuse us. But now we're concentrating on 1 or a number. Okay? Well, this isn't 1, it's a number. So we're going to have to factor by grouping. Now, the process for the most part is the same, the way we start out at least. We're still going to, let me make a little line here, we're still going to multiply A times C. So that's 9 times 1, which equals 9. And we're still going to list out all of the factors, 3, 3, negative 3, negative 3, 9, 1, negative 9, negative 1. And we are still going to add them up to see which one gives us the middle value of negative 6. And which one is that? Negative 6, that would be my second set of negative 3. Now, this is where it becomes different. Instead of writing two separate parentheses and just choosing these as my factors, I can't do that anymore because I have a value other than 1 in the front. I'm going to replace negative 6x with these two numbers. I haven't changed the problem. Because isn't negative 3x minus 3x equal to negative 6x? So all I've done is written this in a different manner. That's all I've done. I haven't changed the meaning or changed the problem at all. Now the next step is to put up parentheses. Okay, now I'm actually going to rewrite the problem as I do this just so we can see the comparison. But when you plug in the parentheses, you literally just throw them in. Nothing fancy. Now, some of you, when you made your parentheses, you may have kept the negative on the outside. You never want to keep the negative on the outside. That changes the meaning of the problem. How come? Well, let's pretend we did that. 9x squared minus 3x minus, and then you wrote the 3x plus 1. Well, technically, this negative distributes in, right? So if I were to do that, that gave me negative 3x minus 1. Is negative 3x minus 1 what I wanted? No, I want negative 3x plus 1. That's why we've got to make sure we put that negative sign inside of the parentheses so it doesn't change the meaning of the problem. Okay? All right, now that we have those parentheses, we're going to go ahead and try to simplify. So in this case, I'm going to take out a GCF. 9x squared minus 3x, they share 3x in common. And over here, I'm going to take out a 3x. Well, no, I can't take out anything. And I actually did this incorrect. Hopefully you looked at the screen wrong when I wrote this. This should be 1x. How come? Because I took out an x, so that only left me with 1x. Hopefully you noticed that. I'm human too. I make mistakes, so make sure you're paying attention because you don't want to trust me just because I'm a math teacher. I make mistakes too. All right, so that leaves us at this juncture right here. Now my goal, my very, very, very goal is to get whatever is in parentheses to look exactly the same. Do these look exactly the same? No. What is different? Hopefully you'll say the signs. This is positive while this one's negative, and this is negative while this is positive. What could I do to make them the same? Any ideas? There's actually two things. I could either change the first part or I could change the second part. It doesn't matter which one I want to do. Honestly, it's completely up to you. I'm going to go ahead and change the first one, okay? And the way I'm going to do that is instead of doing a positive 3x, I'm going to take out a negative 3x, okay? So we're going to just, let's see, I don't want to erase this just for the sake of you being able to see it. So I'm going to square this and say this doesn't help. This doesn't help. And then I'm going to draw an arrow down here. I'm going to do the same idea, take out a GCF, but this time I'm going to take out a negative 3x. What does that leave me with? A negative 3x. I took out a negative 3x, so that leaves me with a positive 1. And then here we'll just leave it as is. Now by doing that, by taking out the negative sign, I now have two parentheses that have exactly the same thing. Now, because you have two terms that share something in common, you can take out a GCF again. Now, this is a different idea. We're not used to seeing this, okay? It's a little weird. But we can take this out, this negative 3x plus 1, as a GCF because this term and this term share it, and write whatever is left over. Okay, there's an understood 1 here, so that's why I've written that 1. Now, I know that this looks weird and we're not used to seeing it, but it's the same idea here. You had two separate terms. You took out what these shared in common. There was subtraction between. You took out what they shared in common and multiplied by what was left over. It looks weird because we're taking out a binomial. But you take out that binomial and write whatever is left over. Okay, and we have negative 3x plus 1 times a negative 3x plus 1. Okay, and that leaves me, I was just checking my work. Okay. And when you go ahead and solve that, we can get rid of that squared. It's negative 3x plus 1 equals 0. And when I solve that, that leaves me with x equals a positive 1/3. Perhaps I should show my steps to that. I got negative 3x equals a negative 1. And then x equals a negative 1 divided by a negative 3, which then gets me that positive 1/3. Okay. Again, we had to do this process, which was factoring by grouping, simply because we had the coefficient in the front. Alright, for the sake of the length of this video, I'm going to go ahead and end this video here. There's going to be a part 2 to section 2.4, which I will upload next. But this is factoring with a coefficient other than 1 and with a coefficient of 1. So hopefully you feel a little bit comfortable on how to factor. Okay? Alright, stay tuned for part 2.